Good morning, welcome, and I'm really pumped that you're here. Can everyone see my screen okay, by the way? Thumbs up with the reactions. All right, cool. General housekeeping for us too. Feel free to use chat. Kim is going to be monitoring the chat as well and relaying any questions because I might not see them. But if at any point you have a question, absolutely let us know. Today, we are going to kick things off by acknowledging our range of discomfort when we hear the word data. After that, we're going to talk about how Kim and I ended up in our particular roles, kind of what we do now. And we're going to discuss the different kinds of data work and how much they actually mirror a whole lot of librarianship. We're going to talk about the shape of data and also about how it's a team-based sport. And we're going to wrap it up with hopefully time for a breakout room and some question and answers. And we also have a resource sheet that will be delivered after this is all done. We have some goals for you today in terms of thinking, feeling, and doing. By the end of this session, I want you to be able to walk away thinking that you are already data specialists and that you have the resources and network to leverage the data at your disposal. I want you feeling confident and comfortable and even maybe just a little bit underwhelmed by the initial complexity of a new but honestly familiar challenge. And what I want you also doing is taking advantage of this resource sheet we're going to be handing out and finding a way to tell your own data story that's more than just throwing a statistic on a slide and hoping for the best. I want to make sure we settle into this idea of being uncomfortable because being uncomfortable is always a moment for growth. And if I'm being honest, I've been extremely uncomfortable since I left librarianship. It's been a bit of a journey. So to get us into that mind space and to also give me another moment to have some coffee, we're going to have a moment to watch a little video about discomfort. Let me know if you can hear it.
It is not playing. We need to share screen with sound. So,
Thank you.
Yep. Just pause the video.
Pause
stop sharing.
video. Stop sharing.
Reshare with sound.
Okay. Thank you, Kim. This is why I appreciate you. Share sound. Got it.
And then start from beginning.
And it's yelling at me about my password. Okay. Sorry, friends, for the technical difficulties.
We're good.
A lobster is a soft, mushy animal that lives inside of a rigid shell. That rigid shell does not expand. Well, how can the lobster grow? Well, as the lobster grows, that shell becomes very confining. The lobster feels itself under pressure and uncomfortable. It goes under a rock formation to protect itself from predatory fish, casts off the shell, and produces a new one. Well, eventually, that shell becomes very uncomfortable as it grows back under the rocks. And the lobster repeats this numerous times. The stimulus for the lobster to be able to grow is that it feels uncomfortable. Now, if lobsters had doctors, they would never grow, because as soon as the lobster feels uncomfortable, goes to the doctor, gets a Valium, gets a Percocet, feels fine, never comes off its shell. So I think that we have to realize that times of stress are also times that are signals for growth. And if we use adversity properly, we can grow through adversity.
All right. Thank you for coming on that journey. How we think about being uncomfortable and these moments where we could kind of fight or flight from stress is a moment that I think is really critical. And it was something important in my own growth in data as well. And so it's important to talk about kind of how we got here. So hi, my name is Becca Bley, and I am an analytics engineer for a software company, and I used to be a librarian. So I graduated into the 2008 market crash with a mix of English and psych concentrations, and I didn't have much of an idea on what I wanted to do. And my mother was like, well, you're very organized, and there's a lot of funky people entering librarianship, because she had read some New York Times think pieces. And lacking any better ideas, I got my MLS in 2010. I spent some time as a senior page at Buffalo and Erie County Public Library after graduation, and nearly 2 years later, I landed my first full-time librarian job, and I worked at Damon College for about 7 years. I started as the reference and instruction librarian, and then I rounded out my time as the digital resources and systems librarian. I had a brief stint in corporate research in a strategy department, and I finally achieved my goal, and today I am an analytics engineer for a logistics software company.
Hi, everybody. I'm Kim Herrington. I work at a large healthcare organization, and I'm also the creator of Buffalo Business Intelligence. What I do is, as a data journalist, I help people seek, solicit, and speak information in safe to share environments. For many of you, this might be your first time ever meeting a data journalist, and that's because I'm the first, to my knowledge, of all of Western New York. So I'm growing more through my mentees, but what a data journalist does is we act as an internal consultant. So people from across the organization, when they are building dashboards and things of that nature, they come to see me to have what I call SOS, story or strategy sessions, where people can come and talk with me for a little bit of time from anywhere in the organization about any data sets. I talk to legal, they're allowed to talk to me. And I help them work through whatever problems they're going through, because sometimes you just need to talk to a human. I'm a storyteller and a navigator, and I link them to the people or resources that they need. I'm a data viz muse. As a former improv comedian, I'm used to saying yes and starting new conversations. So whenever a landscape changes, I'm right there ready to jump in and give some new information. I pretty much evangelize as a goal data viz adoption, which means anything from Power BI to Tableau. I'll give you a hint. Don't tell anyone. But all of those fancy graphics and like the fancy charts and graphs that people make are just fancy web pages. Don't tell anyone I told you this. But I promise you that anyone that has passion and wants to get into this field can. But in order to do that, we have to do two things. We have to enhance communication, and we also have to enhance data literacy. Data literacy, in a nutshell, is just making people more curious, creative problem solvers. This is what you guys do every day, is encouraging those thoughts. So I thank each and every one of you. For me, my values, I value enthusiasm and curiosity. If you couldn't tell, trust and collaboration, like with people, with Heidi, who had brought us to you for this presentation today, and flexibility and creativity. Remember, I'm going to be here for you in the chat this entire time. So if you have questions and stuff like that, don't worry about bothering anyone else. Just like pull the chat bar up, open into a new screen. And I will let Becca know if there's anything happening that we need to pause for. So I look forward to chatting with you guys and casting off our lobster shells, really, when it comes to feeling uncomfortable. So thanks, and back to you, Becca.
All right, thank you. Well, I think it is about time for a check-in. Let's take advantage of that chat feature. When you hear the word data, what cat best represents your initial reaction? Because you can take the librarian out of the library, but cats are forever. So go ahead, use your chat. How does the word data make you feel?
I'm seeing a lot of sixes, and that's good. I see 7.
That's awesome.
I see 7 and a 1. Hard 9.
At this point in my career, sometimes it's a hard 9.
Oh yeah. It's definitely on a day-to-day basis that you can go through all 9 cats in
Absolutely.
a single day.
Awesome. Oh, I love that. So the fact of the matter is, you guys are already good at this. And whether you're on the front end of a database or in the catalog doing research, or maybe you're in the back end curating a collection, or in my case, building data pipelines, or maybe you're acquiring new materials, a lot of this work looks and feels exactly the same, just with very different patrons. And because we love video clips, we're going to share just one more, because maybe you, like me, you're still waking up just a little bit.
I'm sure there's someone out here could give us directions. Oh, look at that little egg guy. He's got on one of those hats that smart people wear. I bet he could help us. Come on.
Oh, hello, sir. Interesting. You don't seem to have a search history. Well, let's start one for you. What can Knowsmore help you find today? Umbrella, umbrage, umami?
No.
Noah's Ark, no doubt. Nordstrom Rack, ergonomics, urban outfitters, cool.
Looks like no one put Humpty Dumpty together again. This guy's a little soft-boiled.
I'm pretty sure he's just trying to guess what you're gonna say.
Yes, I'm sorry, but my autofill is a touch aggressive today.
Let me try. eBay Sugar Rush steering wheel.
Oh, I only found one result for your query. Isn't that interesting?
What? How did you...
The internet's very intuitive. Thank you, Mr. Nosemore.
Well, you're welcome.
So I love this clip from Wreck-It Ralph for a number of reasons. He really represents any typical person who is seeking knowledge, and he needs to use the tools available to him to search for what he needs without really knowing ahead of time what the correct question is to get the answer he's looking for. We also see somebody who is extremely comfortable navigating the tools that are provided by an expert in resource and collection management. And it is the same in data work as it is in librarianship. So I want to talk about kind of the different buckets of data work. And a lot of it can be, broadly speaking, divided into three main categories. We have data engineers, data analysts, and data scientists. Data engineers are the acquisitions and cataloging experts with a sprinkling of systems work. They prepare the data, they run tests on it for integrity and validation, eliminate duplicates. Their primary focus is often in the overall architecture and planning of a company's data structure. How does the data get from point A over to point B? Data analysts are the reference and instruction librarians. They live at point B. They're utilizing the cleaned data created and piped over by the engineers to help people, primarily businesses, answer questions and make decisions about what to do next. And the data scientist analyzes and interprets complex data. In a lot of ways, perhaps our best analogy here is that they're kind of the library directors or perhaps the collection development experts. They're the planners. They organize and operate upon gigs of data, and they deal in things like machine learning models and AI and predictive analytics, all big buzzwords right now. And these are the folks with the scope that have enough scope to think long-term about the directions things should go in, because they've synthesized each part of their data story to make a guess at what happens next. But the truth of the matter is that analysts and scientists are only as good as their engineers, which is kind of where I wanted to be. I didn't want to make business level decisions, and I'm not comfortable predicting the future because machine learning is only as good as the data you feed it. And there are some problems in there right now in terms of ethics. But building the strongest possible foundation for everybody else to be able to do that kind of work, that's the best. That's the sweet spot, I think, for a lot of folks who work in collection management in a way. And so my actual title of analytics engineer is a little bit newer, and it sits right about here. Data engineers would probably prefer to focus on the mechanisms that move the data rather than describing it to others. And this is where the analytics engineer came in. And they needed somebody who could provide clarity and descriptions to the analysts and the scientists. So analytics engineers build data models and provide documentation for end users, and the analysts use those models to, along with a glossary or an index of what all of those different fields are. And it felt a lot, this work feels a lot like building a research pathfinder, I would say. And at the time I applied and interviewed for this job, I didn't know how appropriate it was. There was a gathering that took place in New York City a few years ago for folks who specialize in one of the tools I kind of work with. It would be like a bunch of EBSCO users getting together. And one of the speakers described this title as the person who curates an organization's data and acts as a resource for those who want to make use of it. And further, the analytics engineer is a steward of organizational knowledge and not a researcher answering a specific question. The analytics engineer curates the catalog so that the researchers can do their work more effectively. And that is easily one of the best descriptions I have ever heard of librarianship to ever come from a non-librarian. And, there's many more kinds of data work, such as data journalism or data governance. Who owns what data? Where is it? Who has power over it? Are there duplicates? That kind of thing. And so the more I learned about it, the more I realized that all of this work was a reflection of something I already understood, just through a different lens. A big part of what I want to communicate today is that a library collection, carefully organized with unique primary keys for each item, is data and likely even inspired the structure that's used today. Additionally, I feel like all our brains are already wired for this sort of work, even if the more technical aspects are unfamiliar. The familiarity with metadata and MARC records alone is enough to translate these concepts. And just like with data, you have an opportunity to ask it what it wants to tell you. What does it need? How can you tend to it? What is it trying to tell you about itself? And even further, it's your data. When I found this path, I was told that the best way to begin learning how to handle data is to become extremely comfortable with a single data set. Know it as well as you know your favorite book. When you know your data, you are more likely to understand what you're seeing, and you can spot outliers and edge cases and duplicates. You can say, oh, that definitely doesn't belong here because I know my collection. Not only do common library rules correspond with common data rules, the departments themselves each have their own unique data sets that make up the entirety of the library's data story. Circulation statistics, acquisitions reports, cataloging and MARC records, reference statistics, systems data and usage statistics, and even the physical attributes of the library like gate counts all culminate to tell a unique story about the entirety that is your library. And there are so many different opportunities for projects in your particular institution. Data work can be a whole lot more than just reporting and statistics. Sometimes it's about making life easier, even if the thinky work gets front-loaded. My very first library data project involved our EBL ebook collection that we actually got through WinnyLurk, and the older, clunkier discovery tool we had at the time. This was easily 10 years ago. It might have been central search. It might have been some federated search, I'm not sure. But I noticed that our EBL holdings didn't show up accurately in discovery, and it led me down this rabbit hole of comparing catalog searches to discovery back to the EBL search. Something wasn't right. And according to the director at the time, other organizations were struggling to connect these two particular services. I spent far too long digging into the back end, trying to figure out if there is a way to automatically, hit a checkbox and make it work. But I found that we had a tech mismatch, and it really just couldn't be done with a few clicks. But I had a spreadsheet. And part of growing up as a nerdy millennial is you gain this sense of knowing what a computer should be capable of doing, even if you don't know how to do it, even if it takes a little coaxing. So I had a spreadsheet of all of the ebooks we had through EBL and 9 maxed out spreadsheets of every possible EBL book available in that discovery tool. It was really big. And I picked the brain of a colleague in another department, which is a part of this work. It's networking, it's asking other people what they know how to do. And this person, this person had played with Excel a whole lot more than I had at the time. I knew there had to be a way to get Excel to tell me which titles in my Excel sheet existed in the pile of other spreadsheets and in what rows, because the discovery tool could be populated by a CSV, a spreadsheet, a TSV, what have you. I didn't want to compile tens of thousands of books and their metadata by hand. So this friend very casually said, oh, you just need a VLOOKUP, and off he went. And he just, what did he call it? I talked to him about this last night, and he called it a knowledge grenade. And he just threw this in my lap, and he just off he went to a meeting. And it was my very first complex formula, and it took some time, but I figured it out. And I think autofill wasn't even working, so I was clicking and dragging and like losing my spot. And it was a mess, and it took weeks. But I gained this very deep sense of satisfaction from having figured this out. And it's partly why I have continued to pursue this sort of work. I just really love banging my head against a wall until I find a missing comma. At this core, this was a pattern matching exercise. I needed to know what piece of information, what data they shared so that the VLOOKUP formula could find a match. And I didn't trust title matching because capitalization and subtitles and punctuation can create false negatives. And it turned out that a very small piece of the call number and the very end of the book's link were the same. So I probably created a blank column and told it to take like the last 8 digits off of the hyperlink and put it over there. And without realizing it, I had begun to do the sort of granular data work that I would pursue in earnest at my next job providing competitive intelligence and demographic statistics for a healthcare company. I used code to read very ugly PDF tables, and I cleaned that data based on just pattern matching and replacement. I didn't necessarily need to know what I was looking at. I just needed to spot the patterns. So let's have another quick check-in in the chat. I would like you to tell me if you have ever found yourself having difficulty, much as I did in this moment, getting from point A to point B, and this time our rating scale is dogs. So yes, unsure, and no. Have you ever had difficulty getting from point A to point B with data, with any of the work that you do today? Ooh, wow, that chat number is going up.
Yeah, we're seeing the sometimes, like the dog in the middle.
Oh man, yeah, it's so tough when you know you should be able to do something and you just don't know how, and you never know who the person is that's just going to launch that knowledge grenade at you and just change everything. Mm-hmm. So I want to offer some general guidance on what it looks like to work with data, like in a more technical capacity, but we're not going to get too into the weeds. The biggest part of this kind of work is the shape of data, and you get it into the correct shape by cleaning it. It's called data cleaning. And about 90 to 95% of data work is cleaning. It's the sort of preparation work that anybody with a crafting hobby, I think, can recognize. This was knitting. It's practicing your pattern repeat with different size needles and then blocking it to make sure it's the right size you need it to be. If it's sewing, you are washing and ironing your fabric, you're ironing your pattern pieces before you even cut. It's carefully placing the pins and making sure, you know, your hem is straight. And if this is woodworking, it's that old adage of measuring twice and cutting once. It's going over every single piece of wood with a close eye to spot imperfections and warps. It's the work that feels super tedious, and it makes the rest of the project after that way easier. In data, it's making sure that that all of the data types are the same. Sometimes you can pull in a data set that's full of excessive columns or mixtures of numbers and words and Booleans, and sometimes it's just really a mess. And when you clean the data, you group everything so that the formats are all the same. Numbers stay with numbers, strings with strings, Booleans are grouped with other Booleans. And it's this process that fine-tunes it so that the actual analysis, the story can reveal itself and you don't get stuck with weird outliers and then going back to your initial work and cleaning it again and going back. You want to get this stuff done at the beginning. And I am the first to say that that is not always as easy as it sounds. Anybody who has ever worked in Excel knows that this is a challenge. Dates in particular are very difficult, especially if the year is a 2-digit and you just want to use a dropdown that tells it's a date and then it turns into a strange 8-digit number. Where did that even come from? I don't know. I don't have a silver bullet on this one. I use find and replace constantly. That is one of, I think, the most underappreciated things in computers is the Control F and change everything. Ultimately, this concept is rooted in what we call tidy data. It is the foundation of all data work, and it has nothing to do with programming. It has nothing to do with complex formulas or anything complicated. It is the rule set for how we shape data, and there are only three rules. Every column is a variable, every row is an observation, and every cell is a single value. What happens most of the time when people use Excel, especially people who aren't as familiar with tidy data rules, is that they craft spreadsheets that are maximized for human readability rather than machine. This can often create very wide spreadsheets rather than very long. And it takes a lot more effort for computers to process a lot of columns compared to a lot of rows. Wide is just slower. And even just as, you know, a living, breathing human, I would 1,000 times rather use my scroll wheel to go up and down rather than like clicking and moving the bar at the bottom of Excel left to right. Like that's, I don't want to deal with that. I don't have time. So when data scientists are working with millions of rows of data, it needs to be as efficient as possible. And I want to show you what this looks like, because I'm talking about Excel a lot because I think we all probably have access to Excel. And if you can make your Excel life easier, you're going to be a lot happier. So in this example, we have popular music rankings in the year 2000, and there's a rating for each song by week, and this is a very wide table. And this would make a lot of sense for somebody who might see this table tacked on a corkboard and they want to cross-reference, oh, here's the song they want, here's the week that they're interested in, and kind of like a multiplication table, you just zero in on what it is you're looking for. But that's not how computers want this to work. What's really kind of hindering us here is that having those week numbers listed as column headers doesn't really give us any kind of special functionality. It would be much more helpful in Excel if we could filter this by week, because it's actually a very helpful variable. So this table really just needs to pivot just a little bit, not a pivot table, just a little pivot. Then it can be a pivot table. So a tidy data approach will flip that row of week numbers down into its own column and pull all of the ranks with it. That means that the first 3 columns are going to repeat themselves a lot. We now have over 5,300 rows, but only 5 columns. And this also means that now we can filter in a much more meaningful way. And one of the things that I strive for, this is really just a me thing, depending on the data I am working with, I really only strive to have 1 row of numbers. Like we had rows of numbers, now we just have 1. And I feel like that is a good goal. It is a guideline, it is not a rule. Again, I don't want to get too into the weeds of how Excel works. There's so many YouTube channels out there, so many help guides on how to do these things. I just want to plant kind of foundational thoughts in your head. So I want to talk more about the different roles that are involved when doing data work, because there is a role for everybody. You as an individual may have a question, and perhaps you enlist the expertise of one of your coworkers who's good at Excel and likes that tedious work. Maybe you know a teacher or a faculty member or a community member who has done research in this field and can point you in the right direction or even provide you with interesting data. Or maybe you're familiar with a local nonprofit that researches aspects of this topic that you're interested in. But maybe you don't know any of those people. Maybe you know this person. Maybe you know the person who knows everybody else. And that's the beauty of a network. That's the beauty of the spider web that can connect everybody with varied talents that can all contribute. It's not on any one individual to do this sort of work alone. But maybe you're sitting here and feeling really lost and confused, like you don't have a spot on this team. But you are not out of the game yet. You still have a role. You actually have one of the most important roles. You're the audience. In order to tell a library's complete story, it may take a lot of trial and error to create charts and graphs and other sorts of visualizations that make sense to the audience. Without an audience, without somebody to read it, a tree falls in a forest, charts can't do much. There are certainly best chart options for the kind of data you're working with. There are plenty of guides on the internet on what is the best kind of chart for the story you're trying to tell. There's line charts, bar charts, distributions. We all hate pie charts right now. I hate to break it to you. They are out. Nobody wants pie charts. But if nobody can read these charts, if nobody can make sense of them, they aren't going to be particularly helpful. In my opinion, this is just my thoughts. The best visualizations are a balance between clarity and brevity. Clean lines are very important. People shouldn't have to squint or spend too long on a legend to figure out what colors go with what shape or what line. It's very easy to over-engineer a chart, to have too many words, too many descriptions, too many lines, too many colors. And this is the place where, for data analysts, the science meets the art. So it follows that people can get very attached to the work they create. And so when you provide feedback as the audience member, as somebody who has been approached to provide feedback, it's important to do so with compassion and the knowledge that somebody worked very hard on something that might be completely atrocious. Be kind. So Kim and I are gonna take a look at a few different kinds of charts and provide some thoughts on them. From here on out, this is really very much subjective opinion on our parts. So up to you to agree or not. So we have this chart of non-mortgage debt that is outstanding in the US. And for me personally, as I mentioned, good charts have very little excessive marking. I like that these lines are distinct colors. They all have the same level of richness. They're not blending pastels with earth tones and jewel tones. I might personally download some kind of colorblind color set. Those exist for things like Power BI and Tableau. The pink and purple are a little close, but I think that, you know, they fixed that by having the legend labels right next to the endpoints of the lines. So even if you did have a colorblind audience, they would still be able to figure out what line goes with what category. I think the text takes advantage of inferred meaning. The $ and the y-axis label are very close to one another, so we get to infer, okay, these things are connected, and then they don't have to worry about putting a $ the rest of the way down. And I feel like that reduces a lot of the clutter. I also like that they followed the same pattern with indicating 2004 and then just using 2-digit years the rest of the way, because you got to respect your audience and their intelligence. And since there's no $ here and this is all written out, it's nice and clean. And I like that they do not extend the y-axis lines across the length of the chart, because a line chart is meant to show a trend. It's not about necessarily pinpointing one exact data point like you would with a bar chart. So I like that this is overall very clean. 10 out of 10. What do you think, Kim?
For this one, I think it's definitely a great place to show the different colors that are aligned with the lines. That definitely is one of my favorite things about it, in that you're not guessing what line means what. I definitely do like that there has been, the noise has been reduced for this. One of the things when it comes to seeing lots of charts together on a graph, or like lots of charts together on a single page, is understanding the purpose for why a person is here. And I feel like this one is great, but at the same time, I feel like it could go a little further of giving a little bit more information to say what the point is that they're trying to make here. And that is, you know, it appears for this one that student loans has the most debt outstanding for this. But again, it really depends. And we have to remember that our data literacy and our storytelling both need to improve, both on the side of the data literacy of our readers that are looking at this, and of our audience, to be able to understand like what the different axes mean. But then the storytelling of the people that create the graph need to be up there. But overall, it's pretty solid. And I'm just happy that the source is there. I just actually wish the source was linkable so I could actually find it.
And we are going to talk about format and context in a bit. We have a classic correlation does not equal causation issue here. And this dual axis line chart relates the number of venomous spider deaths on the right to the number of letters in the winning words in the Scripps National Spelling Bee on the left. Is it funny? Absolutely. The number of shark bites increases with the number of snow cone sales. That doesn't mean they're related. So, you know, the correlation issue, or the correlation conundrum rather, really should force you to ask the question, but why? What is the point of this chart? As you just mentioned with the other one, why do we care about this? I'm not sure. And if you don't have a good answer to that question, it may be time to reevaluate what it is you're trying to say. Would you agree?
Correct. I don't have anything to add for this one.
That's fine. So we mentioned that pie charts are out, donut charts are in. I like that donut charts are very clean. They offer a more realistic perspective of the actual proportion, which can get lost a little bit in a thick pie chart. And I like that this is being used as kind of a completion meter, kind of the way that some places will use bar charts, like, oh, we reached our funding goal. This is another way of doing that. And I think sometimes when you come in without formal training in some of these things, it allows you some more creativity as to how you might use a chart. Now, there are no labels here. I'm not actually sure what this is for, but I like that it's clean, and I liked that they were using it in a kind of neat way that wasn't just, this is this proportion of this thing. It's really, how close are we to our goal? I think that's a fun way of doing it.
For this one in particular, don't be afraid though. When all else fails, I want everyone to just like think about like what's the thing that you're going to fall back on. Always fall back on a bar chart. Like if you're trying to first look at data, first look at it in a table and then try it in a bar, because that's going to be your go-to. And like there's ways that you can filter it to be showing in ascending or descending order to kind of show what the pieces are the most important. Another great one to look at that would show this information in a singular line would be in a bullet graph. So that's another one of my favorites.
Mm-hmm. Oh, you love fun charts.
Well, that's my job.
It is. It is. So here's
Is
why
my
we
favorite.
Yeah, no, here's why we dislike pie charts. Now this is obviously a very horrendous example. Like who can tell all those colors apart? Like really, nobody. It's impossible to read, and it's worth noting that if a colleague handed you something that made you think of this, I want you to take a moment before you respond, because, whew, wow, this is a lot. Kim, you actually have a very good guidance on this front with the favorite things.
So when it comes to the pie chart in particular, so I did just put a comment in the chat. If a pie chart is bad, a 3D pie chart is like 10 times worse. Just say no to 3D anything when it comes to showing data visualizations, because when you think about your visual perception, it can be skewed. And you've got all these different, you've got those visual tricks, like you have, like, do you see the old woman or do you see the young woman? You want to make things as simple as possible so your data is not misinterpreted. So this in particular is just, there's no words.
There are no words. Well,
I can give you an example of what those bullet charts look like. I will find you one. There you go.
all right.
I'll put it in the chat.
Perfect. So sometimes a chart can look really cool and different people can have different opinions on it. Now, Kim, I never did tell you that I found this in a Google image search for bad chart. Kim really likes this chart. I hadn't told her that until now. Sometimes, our opinions on these things meet in the middle, and I keep saying that the audience is everything, but so too is the format. This chart would be very good if it was interactive. If it was a web-based chart that people could click on to fade certain lines into the background, help isolate different bars of interest. But as a standalone picture, I'm not particularly enamored with it. Like, it looks really cool, but what is it trying to do? The middle axis isn't very clear to me. It doesn't stand out enough to show that they're connecting the countries at the top to the subjects at the bottom. Others and organizations over on the right is relatively ambiguous. And yeah, I don't love it, but I know, Kim, you like this chart a whole lot.
Yeah, like, so a chord diagram for me is a chord diagram is also known as a ribbon chart. And this one in particular, like, I can see that it's a little bit confusing. If you never understood what a ribbon chart was, or a chord diagram, or a Sankey, you might not be able to interpret this chart. Again, that's why knowing your audience is super important. So for me, I have familiarity with these types of things, so I can see that the width of the ribbons can show me big relationships. So whereas we're looking at the USA, I can see that a large portion of them go to, the economic sciences piece. And then if I'm looking at the economic sciences piece, I can just the same say, oh, where's that large chunk tying back to? Oh, it's tying back to the USA. So again, it really depends on what type of information you're trying to convey. And also the format in which you're presenting the information. Like, so if I was presenting this type of information in a dynamic platform such as Power BI or Tableau, I could actually click on each one of these ribbons, or I could hover over it, and it would be able to tell me the exact percentages or the numbers as I hovered over the various ribbons. That would give me more information. But again, it is a little bit up to personal preference. It is an art. Data visualization is an art. It's a science that requires everyone's inputs for this. But the point is in the end, you can tell if a chart is good or bad based upon if people are discussing the implications of the data presented. If there are people who start asking questions about, like, well, why is it that the USA has so many Nobel laureates for economic sciences, and that stimulates discussion. If people start having discussions around the axes, the labels, the colors and stuff like that, to me, that's actually a very ineffective chart, because it's not making it about the data, it's making it about, like, the format of the chart. And this is a term that I learned from our mutual friend, Steve, that I invite you to take with you. It's an actual term. It's called bike shedding. So in this, that's the process of, if you are, there was like people that were building a Googleplex, and they're building this massive plan out, and they have everything planned, and all they have to do is just go build it. But the problem is they actually had decided, oops, we have to put the bike shed for our employees on this lot. And they were so concerned about where to deal with that one little detail of like where to put this tiny little bike shed on this massive plot, that they'd never actually got to build the big thing, because they were so hung up on the details of this like tiny, relatively insignificant little thing compared to everything else. So I invite you to take that word bike shedding back with you, because you'll find as you're working with people, as they are running around and not finishing the thing, there is a term for it. Continue.
That was great. Thank you. Yeah, I would not put this particular one in a slide. How you're delivering this information really is important. So sometimes, I know I said at the beginning you shouldn't do it, but sometimes at the end of the day, all you really need to do is to throw a statistic up. I know I said not to do that, but like, if you are presenting, if you are going through slides, sometimes you just need that punch and get straight to the point without a lot of fuss. So we kicked off this meeting talking about aspirations for thinking, feeling, and doing. And I hope that you're now thinking that you are already a data specialist and that you know people that can help you leverage your data. I hope you're feeling a little bit more confident and comfortable. And I do want you to take advantage of not only the resource sheet that we're going to have sent out, but also, this community of people that we have here this morning. And I think we have some time for that breakout room. So I want you to be able to tell your data story in a way that's more than just throwing your statistics on a slide, unless that's what's needed. Remember that it's okay to find comfort in discomfort, and that you're already good at this. So with that, it's time to have a brief breakout session. Kim, are you able to set those up?
Yep, I should be able to.
Cool.
There we go.
So your question to discuss, and this is just a jumping off point, you are not required to talk about this. If you want to come back and tell us you talked about something else, that is totally cool. But if you had a magic wand, what problem would you solve? And discuss what data you might need to solve it. So this will come out as a PDF, but essentially there are spots for you to locate existing data sets. There are some links to learn more about how to work with data. There are different networks, meetup groups, user groups that can help you get more integrated into this kind of thought space. There are YouTube channels on how to learn a whole lot of things. There are podcasts for people who are talking about things like business intelligence. I think business intelligence is a good area of focus for just about anybody. It is the concept of all of this storytelling. And finally, we have books. So, whether or not you want to get these through interlibrary loan or add them to your own collection, there's a bunch of things here that should help you get where you want to go. All of these blue lines are hyperlinked. So if you have any troubles, let us know, but this will get sent out to everybody.
I did just post a new version in there.
And there are anonymous ducks showing up.
Wonderful.
I think
okay.
It worked.
Good. So people should be able to have viewing capabilities for this. So as Becca's got that up on her screen, check out those different things. So my specialty is those data networks. Buffalo Business Intelligence, that's our next event that's actually coming up for Buffalo specific, where we bring together people that are using data from all different industries using all sorts of tools. If you don't have the skills that you think that you need, this is the place to get connected with other people in your community in a safe and welcoming environment, where we have people of all skill levels that come to this thing that have never come to data stuff before. This is definitely the place to be. Let's see. Is there any other questions that other people have?
I will just interject one final point. The R for data science in Learn Data, that's where they get in. That it is a programming language, but that is the kind of digital book where they talk about tidy data concepts. So all of those 3 rules, that comes from R for data science. So if you want to learn more about that, that's the place to go. It's a free resource.
So excited to have people from different time zones in here.
Absolutely.
This is wonderful.
All right. I have to attend my other time zone meeting.
So you go ahead. Becca is going to head out. I don't know if Heidi or Caitlin have anything else. I can stay on in the interim for as people have extra questions, because I knew that we might have to stay a little bit longer. But let us know.